All right, so section 5-4, as I said, is all word problems. So we are going to fill in some of these things here as we go through the word problems because you might not be familiar with some of those words yet. So you're going to be writing equations in the form of y equals mx plus b. Remember that b is always just a number. It's a constant. It never changes. This mx term, that's called your variable term because depending upon what x is, depends upon the value of that term. So you're always going to you have to decipher between what's the constant amount, the thing that doesn't change in this word problem, versus what's the thing that varies. For instance, what things are constant in life? Okay, yes, death and taxes, right? You're always going to have those. Does temperature change? Yes. Does the price of gas change? Yes. What if you got in a taxi? Now, we don't have a lot of taxi service here, right? It's not like back east. A lot of people use taxis back east. How many of you have actually been in a taxi? Oh, well, that's excellent. The minute you get into a taxi, whether or not you go anywhere, you get in, you close the door, don't they charge you like $3? Yeah. Give or take, depending upon the taxi? So it doesn't matter if you go any distance at all, it's going to cost you $3 to sit in the taxi. Woohoo, right? That's your constant amount. And then they charge you what? Yeah, they charge you mileage, so money per mile, right? So depending upon how many miles you go, depends upon how much more it's going to cost you. But they will always, because maybe you go 1 mile, well, the reason why they charge you that $3, $5, whatever it is because they want to make it worth their while to actually go somewhere. Like if you have you been to New York City? Who's been to New York City? Okay. New York City, sometimes you'll get in a taxi cab. In fact, my grandmother used to get in a taxi cab just across the street. Because in some places in New York City, isn't it hard to cross the street before the light changes? And how are the drivers in New York City? Very aggressive. So my little old grandmother, who couldn't walk very fast, she'd have to get in a taxi just to cross the street. So would a taxi cab driver want to pick her up? No. So that's why they're going to charge you that kind of base fee. Most of you have cell phones, right? It used to be that they would charge you for minutes on top of a base charge. Most of you have like an all-inclusive data package now, right? So it doesn't matter how much data you use or how many minutes you use. Some of you still have the shared minute plans though, right? Depends on your carrier. For instance, in my household, I know it's going to cost $60 for a phone plan, even if we don't talk at all on the phone or use any data at all. But the minute we go over my plan, I think we have 1,400 minutes. I never go over 700, but if we have 1,400 minutes, then wouldn't they start to charge me? So I'd have to pay like $60 for 1,400 minutes. And then if I go over that, the charge is pretty high. So my variable charge is what I go over the minutes. My constant charge is, what they're charging me to stay in those minutes. All right, so we're going to find some keywords as we go along here for rate of change. What else do you know of as kind of rate of change? We've talked about it before. Something you do practically every day or you are involved with practically every day. What? How do you get to school? A lot of you get to school via car, right? What does the car do? It drives how? How? How fast? How fast does the car go?
100 miles per hour. 45 to 50.
What? Miles per hour. So one of the key words that you should be familiar with is the word per. Let's say that I type 80 words per minute. Isn't that a rate? 80 words per minute is a variable rate. Anything that's a rate. If I go to the grocery store and buy bananas, it's going to cost me, 39 cents per pound. So there's that per again. Depends on how many pounds I buy, what the cost is going to be, right? So per is one of those words that means a rate of change, and a rate of change is always a variable. And so we're going to look at what are words that would refer to a starting point. Nope. Okay, well, let's look at a word problem and we'll see if we can find some of them. So your very first step in your word problem is always going to be to what? What's your let statement do? Define your variables. So write that down. You should be defining at least 2 variables in your let statement. And then your second step is to do what? What do you do in the middle here? Before you solve it. Write or create an equation, right? So write an equation and solve it. And then what's the last thing you do? Okay, so write your answer in a complete sentence. You know all that stuff, right? Okay, so then let's start to dissect these. I'm going to be looking for keywords and things that represent my variable thing versus my constant thing, because I'm writing it in the form of y equals mx plus b. So a large pizza, instead of costs, I really would rather you write the word is. A large pizza is $10.25. I'm assuming that's a large cheese pizza. Then it says each additional topping is 75 cents more per topping. Per. Did you see that word? Yeah, so the question is, write a linear model, that just means an equation that's in the form of a line. Write a linear model in slope-intercept form, isn't that y equals mx plus b? For the cost of the pizza C, aren't they telling you what variables to use? Cost of the pizza C, so I am going to let C equal the cost of the pizza in terms of the number of toppings X purchased. So the number of toppings X is X. So we saw that word per, right? Do we know what the cost of our pizza is? Yeah, they told us, right? So if I'm going to write something in the form of y equals mx plus b, I have a large pizza is $10.25, and the other information they gave me was each additional topping is 75 cents more per topping. Which one of those is a variable? Changes. Stephanie? Yeah. So shouldn't this one represent M or B? This is our M, right? Our 75 cents. And what's B then? The 10.25 doesn't change. If you don't put any toppings on your pizza, won't it be 10.25? If you put pepperoni on your pizza, now it's 10.25 plus 75 cents. If you put pepperoni and sausage, now it's 10.25 plus 2.75 cents, right? And it can just go up from there. So how are you going to write your equation? Instead of y, what are we using instead of y?
Wait, why?
Well, let's talk about this. If M is the if M is the 75 cents and B is our 10.25, wouldn't y be the total cost? So, but instead, what do they want you to use? Because isn't this going to give us our total cost? Our base pizza amount plus our toppings. So instead of y, we are writing C, and we're breaking you out of that habit of always having y's and x's in your equation. And then the variable amount M is 75 cents. We said we're going to let X be the number of toppings. So don't we multiply 75 cents by however many toppings we get on our pizza? We don't know how many toppings we're going to get on our pizza. Doesn't it change per customer? Every customer has a different amount. But I will always add to the number of toppings the base price of the pizza, which is $10.25. So we did have to use instead of YC, only because they told us to. If they didn't, then you could have still used Y. All right, now is there any, did they tell us how many toppings that we're going to buy? No. Is there any way for me to come up with the total cost of the pizza because they haven't given me enough information? So there are a couple of questions on your homework where there is no question to answer. You don't have to do that part. And so for the first couple of questions on your homework, it's going to be like that. So you're just defining your variables and you're setting up an equation to solve. Okay. Then look at B. Budget rental car company charges a flat fee, $25. What does that mean, flat fee? Flat fee means it doesn't change, right? So remember we were trying to find words for a starting point or something that is a constant? So up here, put flat fee. Anytime you see the words flat fee, that's going to represent your B, the thing that doesn't change. So flat fee. So I know right now, immediately I'm going to write B right here. Flat fee. Then plus, they do 17 cents per mile. Isn't there that per word again? So what is that 17 going to represent? Our M. So you are to write a linear model in slope-intercept form for the cost C. So here they're telling me the cost is C in terms of the number of miles driven, X. So the number of miles driven will be our X. So let C equal, and I'm going to put here total cost, and X is equal to number of miles driven. So you set up the equation to solve in y equals mx plus b form using the proper variables. Let's see what you come up with. And then compare it with those around you. So see if somebody else has the same answer as you. And if it's different, can it be different? So share. Compare person behind you, in front of you, to the side of you. You don't like this problem?
Huh?
Is that what you said? You don't like this problem?
No, he said Prince problem, but no, I like my problem.
That's it.
I said it was an easy problem.
Oh, okay. What does that mean? Okay, so tell me what you came up with. What'd you come up with? Raise your hand. Who wants to share? Sean? No, the middle part here. You're right. He's right. There's no question and answer. What'd you put for your equation though?
C equals 17 cents.
TJ, turn all the way around now. So that's correct. That's correct. Make sure that your decimal point is clear, and to make sure it's clear, it's always great to put a 0 in front of it. If I can't see your decimal point, if it's really light and tentative, I will probably mark it wrong as it's not there. So make sure it's clearly seen. All right, and so as Ishan said, there is no question to answer. Now, if I told you how many miles we drove, could you figure out the total cost?
Yeah.
Yes. All right, so then let's look at C. At noon, Jesse is 650 miles from home. So we might have to draw a picture for this one. We'll see. If Jesse is traveling towards home, so here's oftentimes what I'll do here in the middle. Here's my house, or Jesse's house. Okay? And then Jesse is right here. 650 miles from home. Then it says Jesse is traveling towards home, so he is going in this direction. Is the distance between him and the house increasing or decreasing? Decreasing. So oftentimes a picture helps to see what's going on. Because in your homework it might say that you're traveling away from home. And wouldn't that be increasing the distance? Okay. And he is going 55 miles per hour. Isn't that one of those pers? So what does that mean? Is this M or B? It is M. So the 55 is going to be our M. What comes in front of the 650? Is. Look at question number or question letter A. What came in front of the B on this one? The word is. So oftentimes when you see the word is, that is referring to a flat rate, flat fee, a flat amount. So you might want to put up here the word is. Not always, but oftentimes what number follows is oftentimes going to be your B. In this case, the 650 you'll see is going to become our B, because watch what the question says. Write an equation in slope-intercept form that gives Jesse's distance from home D, so his distance from home is D, in terms of the time T. And we'll talk about what they said there in a minute. So we're going to let D equal distance from home and then T will equal time. So that's why we said that B is oftentimes a starting point. What was the starting point from home? 650 miles. That's why the 650 is our B. It's a starting point. It's where you travel. Because sometimes we're going to start with something and add or subtract to it. Do you ever have a bank account? Right? You have a bank account, savings account, or checking account? Hopefully you put money in that savings account, right? And hopefully you are adding to it rather than subtracting from it. But the amount that you initially invested would be your starting point or your B. And then however many, maybe you put in a certain amount of dollars per month. Wouldn't that increase your account balance? What if you took out money per month? That would decrease your account balance. So you have to pay attention to whether your M is a positive number or a negative number. Is it increasing that starting point or decreasing the starting point? Because we are going to put the M in front of the starting point. So, is this M, 55 miles per hour, is it increasing Jesse's distance from home or decreasing it? If he's going towards home, is it shortening the distance or increasing the distance? It's shortening it. We want to reduce it, right? So this 55 is going to end up being a negative. Isn't that the only way to reduce the distance? Okay. So when I write my equation, distance from home, total distance from home would go in the same place as total cost would go, right? So that's our Y, isn't it? Then our variable amount is 55 miles per hour. And what they say, so per hour. So this time we're not letting hour be X, are we? We're letting it be T. So 55 times T, but it's got to be a negative 55 or it won't reduce our distance from home. Then our starting point is 650 miles. Normally you'd write it 650 minus 55T. If you write it that way, I'm not going to mark you wrong here. But this is in proper slope-intercept form. All I'd have to do is change the problem a little bit and say that Jesse is traveling away from home. If he travels away from home, he's increasing the distance, and doesn't this become positive? All right. So then it says, let T equal 0 correspond to noon. All right, so at time T0, that's noon. Now here's the question right here. How far from home is Jesse after 3 hours? So we're going to let T equal 3. So in other words, how far is he from home at 3 p.m., right? How do I solve that? Yeah, plug T into there. So I have D equals negative 55. Instead of T, I'm putting in 3 plus 650. What are 3 55s? 165. So this is negative 165 plus 650. What's 650 minus 100? 550. And then we want to subtract 65. So what's 550 minus 65? 485. And what form of units of measure is that? D is in distance and D is miles, right? So therefore, Jesse is 485 miles from home after 3 hours. Do you have to write all that? Yes. Because I'll ask you when, because it's part of the answer. Question.
How fast was he going?
He was going 55 miles per hour. That's a constant speed. We assume that he's going that constant speed. Does he speed up and slow down? Yes. But we're going to assume it's a constant average of 55 miles per hour. Same as before. Okay. Are you all right with that? Okay. So then look at D. So a store that rents rollerblades charges a flat fee. We've seen that before, right? Of $7.25 plus $1.25 per hour. We've seen that word before as well. Write an equation, slope-intercept form for the cost Y of renting the rollerblades for X hours. So I want you to set up your let statement and your equation to solve. Don't answer the question yet because I want to make sure you have the right equation first. So go ahead and do those parts on your own. So compare with those around you, see if you all have the same equation. All right, so what are you letting Y be? Total cost, right? What are you letting X be? And I would have put number of hours, right? Okay. So this one's nice because you already know it's Y equals MX plus B. So you don't have to switch anything out for X or Y because that's fairly obvious, right? So what do you have? Y equals what? All right, so Y equals 125X plus 725. Again, because it's a cost item, it adds to the cost instead of subtracting from the cost, right? All right, so then they're giving you, how much would you pay if you rent a pair for 4 hours? Have they given you X or have they given you Y for 4 hours? So that's your X. So go ahead and plug in. Y equals 125, and I expect that you ought to be able to multiply 125 times 4. If you have $1 times 4, how many dollars do you have? $4. If you have a quarter times 4 and you have 4 quarters, how much does that equal? $1. So what's $1 plus 4? Was that hard to multiply? No. So it equals 5 plus 725. So what does that equal? And that's in what unit of measure? Dollars. So therefore, answer the question down below here as a statement. You will pay $12.25 if you rent a pair for 4 hours. Whoops. So we only have 2 more. One I'll do with you and one you'll do on your own. So flip it to the back. These aren't so bad, are they? Oh, and by the way, you are going to have a, remember that test, that pre-test that you took over word problems? No, way at the beginning, the first or second week of school, I gave you a bunch of word problems and you had no idea what you were doing? Okay. You're going to have a test on this next week. No, actually, I think I'll give it to you tomorrow. Well, I could give it to you tomorrow or the day of your quiz.
Tomorrow.
I think I'm going to give it to you tomorrow. So all it is word problems. You should be good at them, right? There's consecutive integer problems on there, so make sure you study those, right? And you can ask any questions before tomorrow before I give it to you. Yeah, you're going to have a test over word problems tomorrow. No notes.
Will it go in for this quarter grade?
It will go in for this quarter grade. Maybe next quarter. Depends on how quickly I grade them. I'm thinking it'll go in this quarter. Yes, you have to. But you know what? It's going to be stuff that you've seen. You're going to be fine. If you are comfortable with these word problems, you're going to be comfortable with those ones on the test. You'll be fine. You can only get better. I have to look, but no different than this. They could be. I haven't checked it for a couple weeks. All right, so let's look at this last question. Suppose that the gas tank of a car holds 12 gallons. Is that a change in rate or is that a starting point? Yeah, so holds 12 gallons. This is a starting point, right? So you might want to put on the other side that holds was another word that we saw, right?
We put a plus next to per.
Next to which one?
Next to per.
Oh yeah, that would be good. Very good. So plus, right? All right, so then, so we know that that means that 12 is B, right? So this represents B right there. And that the car uses, what does that imply? Addition or subtraction? Uses? Subtraction. So this implies subtraction, right? And it uses a 1/20th of a gallon per mile. That is a rate, isn't it? So this is M, but isn't our M going to be negative because it uses? If I use gas on my gas tank, does the gas in the tank go up or down? It goes down. If I add gas to my gas tank at a certain rate per minute, does it go up or down? So if I'm at the gas station filling my tank, this would, if I were filling it at 1/20th of a gallon per minute, let's say, then it would be raising the level in my tank. Whereas when I drive a rate per mile, it lowers that amount in my tank. All right, so write an equation for the amount of gas in the car Y. So this is total amount of gas in the car because it will change. In terms of the number of miles driven. So the number of miles driven is our X. So let Y equal total amount of gas in tank. You don't want to confuse that with the 12 gallons currently in there. And then X is number of miles driven. So Y equals, it's my total amount of gas in the tank. My starting point is 12 gallons, right? So I'm going to put the plus 12 here. What's my variable amount? Negative 1/20th X. Then it goes on to ask me a question down below. How far has the car gone when it runs out of gas? This is a different question. When the car runs out of gas, how much is in the tank? 0 gallons, right? Is that X or is that Y? X is your number of miles driven. So they're actually telling you why. They're telling you the amount for Y. They're telling you that you have 0 gallons in your tank. They want to know how far can you drive until you have no gas. So we're going to replace Y with 0. And this is a harder problem. Y with 0, so that equals negative 1/20th X plus 12. We have to use our algebra to solve this, right? So how do you get the 1/20th X by itself? Subtract 12. I'm going to run out of room, so I'm going to do it over here. So I have negative 12 equals negative 1/20th X. So ignore this side without the X. Look at the negative 1/20th X. How do you solve with fractional coefficients? Multiply by the reciprocal. What's the reciprocal of negative 1/20th? Negative 20 over 1. So you still have to multiply by a negative. If you don't multiply by a negative, the negatives won't cancel. And then this gets multiplied by negative 20. Those cancel. Won't you get a positive number here then? What is 20 times 12? 240? Yeah, it should be 240. And what is this units of measure? What does x represent? Miles. So this is in miles. So therefore, the car will run out of gas in 240 miles. So you might want to star this one because it's a little different than the previous ones have been, right? This time you're given y. So now I want you to do f on your own. Decide what your variable thing is, what your constant is. Decide if that variable thing is increasing or decreasing your starting point, your constant. So decide whether it makes it positive or negative. So stop when you get to the equation to solve. What did you let F be? Fahrenheit and C, Celsius. All right, if you're unaware of what the actual formula is, look at how they tell you. So they tell you you multiply Celsius by 9/5. Because they're saying multiply by 9/5, doesn't that mean 9/5 has to be the M? And then they say, then add 32 to it. So 32 has to be my B. How do you know whether it's F equals or C equals? Because you're multiplying Celsius, right? So if you're multiplying Celsius, shouldn't Fahrenheit be the one that's on the left? So Fahrenheit represents our Y. Celsius represents our X. And then now if they give us Fahrenheit or Celsius, we ought to be able to plug it in and solve. So which did they give you? Celsius. So this equals C. So that's the easier one to plug in. So then F equals, now I would write the Celsius as a fraction, negative 20 over 1 plus 32. That way you can cancel the 5 into the 20, right? And what'd you get? What'd you get? Negative 4 on what units of measure? Degrees. So F is equal to that. So therefore, the Fahrenheit temperature is negative 4 degrees when Celsius is negative 20 degrees. So some of these are going to be, difficult, a little fuzzy for you, but for the most part, you ought to be able to do okay.